All right, welcome to Python Coding Lab number 5, April 14th. And once again, we have 3 problems. And I'm going to share the 3 problems, the link with you now. And I'm going to post that in the chat. And then basically you guys can take a look. I'm going to explain those problems as well. So the link is coming up in chat now. I'll give you like 30 seconds to quickly go there and download the files. Meanwhile, I'll open it too. If there are any typos in the file, then just forgive me because today I've not been able to run this code beforehand. Shouldn't be anything, but just giving a disclaimer. Okay, so let's get started. Let me explain the problems. So the problem number 1 we have is called second modified. Okay, that is the file provided to you. Second modified. Basically, the problem is not that complicated. Essentially, you have to complete a function. In this function, you will be given input a string, and you have to return a string in which the second character of the string is modified with an asterisk. So if you're given, let's say, hello, then you have to return this back, asterisk LLO back. So essentially just return the second character modified in the string. The only condition, I think there's one condition you can read that. It's basically if the string is less than length 2, then you don't need to modify the string, essentially. So that's problem number 1. And there is actually, I'm sorry, there is one more condition. You have to modify only when the string is odd length. If the string is even length, then you return the string as it is. And also if the string is less than 2 characters, then basically also you return the string as it is. So 2 conditions. Any questions in this problem? Okay, problem number 2 is called substrings. This problem I have taken from lead code. And so this was in the competition recently. Basically what you have to do here is that you have to complete a function called substrings. Substrings takes in words. Words is a list of words, and you have to return a new list of the words, the words which occur as substring in some other word. So for example, let's take this guy. Let's say this is the input. Then what you return back as an output is, so you're going to scan this, and basically, for example, hero is a substring of superhero. So in our result, we should have a hero. Then as is a substring here in mass. So as will return back as well. Rest, there is no other solution. So any string that appears as substring in any other string, you have to put that in a list, and you have to return that list as an answer. Similarly, if there is no such substring, then basically you return an empty list back. Okay. Any questions on this one? Okay. Third question. It's called traveler. In the problem traveler, you have to navigate through the route that I've given, and in the end tell the coordinate of the final destination. So suppose you have a coordinate system here. That begins at 0, 0. I have given you a list of this type, that something like this, for example, this guy. Okay, so the list essentially contains each item of that list is another list. And give me a second. So each item of this list is another. So this is item number 1. And for example, this is the item number 2. Each item of that list is another list. And the items of that list is a direction and the unit of distance where this point is supposed to travel. So you have to write a function which begins at 0, 0, and then it follows this direction. So I say north 1. So it goes north 1 unit. Then it goes east 1. So it goes east 1 unit. So at this point, the coordinate have become 1, 1. So the function should return this tuple, which is 1, 1 back. So tuple should be of the form x, y, which will be the final destination, final coordinates, once you have traversed all of these that I provided. Any questions? Any question in this one? I provided some sample inputs that you should be able to run and test your code. Okay, if no question, then I will give you your time now, and your time begins now. I will reconvene for the solution at like something like 7:40, 7:45, something like that. All right. All right, solutions. The problem number one was second modifier, and I see a lot of people were able to solve that problem. So let's just quickly look into it. Essentially, you just have to modify the second character and return the string back. So let's say that you have a string, something like this. If it's an odd string, odd length string, then you have to modify it. And in that case, how you have to modify basically is that you have to change this second index here, like that, 0, 1, 2, 3, 4. You have to change the second item here to an asterisk. So essentially, you can just split it into two substrings. Bring this character here, bring this substring here, and then add an asterisk in between, and then just concatenate. That would give you the answer. So let's just quickly finish that code. Shouldn't be that complicated. First thing is I'm going to check if this length of the string is, what did I say, less than 2. If the length of the string is less than 2, then essentially return s as it is. Else, that is, if the length of the string is greater than or equals to 2, then in that case, what we have to do is we have to find the first character, which is 0, then add an asterisk into it, and then append rest of the string from 2 onwards. So let's see if that works. One of the key thing is always taking care of the indexes. So let's see if that works. You run this piece of code and you get okay on some, but you get failure on one because I am not checking one more condition that I need to check. So inside this another else, I can just put one more if, and that if is basically if the string is odd length. So if the len s modulo 2 equals 1, that means if it's odd, then essentially return this. Now I can write this code a little better than this. This should be actually written better than this. So let me write this better than this. So what I'm going to do is I'm going to leave the string unchanged. So only one condition is there in which the string has to be changed, and there are two conditions in which the string does not need to be changed. So rather than nesting so many times, I'm just going to write one single statement here, which is going to be if the length is greater than equals to 2. And len of s modulo 2 equals 1. In that case, return s of 0 plus an asterisk plus s of 2 onwards. Else, in any of the other conditions, basically just return s. Let's see if this code returns the right answer. I'm still getting the answer for the second one is hello. Let's see where the mistake is happening. Does anybody catch any obvious mistake?
The second
Len of s is greater than equals to 2.
being called, right?
What is that?
Second modifying function is not being called anywhere, right?
Is it not being called? Oh, wow. Wow. Too many problems today. My bad, guys. Let me see this. Today I quite prepared these questions very last minute, which is causing this.
I thought that was a trick from you, like you have to go in and fix it.
And I was thinking, what's the problem with logic?
So that was a brilliant trick, like brilliant in that way.
Always happens. One thing or the other. So yeah, so the code is working. So essentially what I did was, initially I used an approach where the code was going through too many nesting and it was not looking that good. So I compressed it into one if statement, because only one specific condition asks me to modify the string. Otherwise, the rest everything else is keeping the string as it is. So catching everything else in the else statement there, and then just modifying the first situation. Looks like there are 2-3 typos in the code today. Let's look at the problem number 2, which is substring. Let me see if there's anything missing here. I hope this is good. This is fixed. Let's just run this code once. So got and expected is something like this, which should be good. There might be a problem actually. Let me see. Here also I'm not calling function, so let me call the function, because let me just call the function really quickly. I'm increasing the font a bit more. And let me call the function. Substring, and then put a closing bracket here. Save it. Let's just run and make sure that we are getting none back everywhere. Okay, that's good, because we are returning none, so that's better. Let's just return an empty list, and that will cause the test to fail. That is good. So now this is properly set up for us to code. So the problem here is basically that we need to check whether one string, but if any string is substring of any other string in this array, then you need to add that string to a list of the strings, and you have to finally return that list of the strings. So how do we do this? Well, the approach that we can use is brute force approach. Simple. So let's suppose you have string as, let's say, universe, and consider all of this as small letters. Suppose you have verse, and suppose you have is, and suppose you have his, something like this. So what we can do is we can have a simple for loop going from left to right, which picks a string here. So it pivots on this one, and then it's going to check it with everything else. So in order to check with everything else, we can write another for loop inside the first for loop. And we can check basically if starting at this point, pivot, 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 all of this, check with verse, check with is, check with his. Then similarly, check for verse and check everywhere else if verse is present in any of these. So similarly, you can do this with two for loop. Or you can also do it with Python as a in membership. So you can just use the in membership to return your answer as well. You can do that too. So let's just quickly write this code. Substrings. So the first thing that we can do is let's just quickly scan through this list. I'm just going to quickly say for X in words, or you can just write for W in words. Okay. Now the problem here is that if I just write if W in words, then this is a problem. Then I can just, let me first initialize this with some kind of a empty result. And then just add result.append W and then return W. This will not work. The reason this will not work is the substring will match. So is will match with is. Everything will match. So you're going to get everything back. This is the answer that you're going to get back. Because superhero will match with superhero. Hero will match with hero. As will match with as will match with as. So how can you avoid that? So instead of iterating over this words, we can iterate over the index and we can check whether when the comparison is being made on the same index, then just ignore it. So suppose I have two loops running. So one loop is I and another loop is j within. So let's say the I is 0 and then j is going to compare I with everything else in the array except 0. So anytime the j is equals to I, we just skip at that point and then compare with everything else. So let's just write that simple logic and then I'm going to improve it a bit further. So I'm going to say, suppose that L equals to len of words. Then I'm going to write something like for I in range L. Right? For j in range L. Right? Now compare the words that are present in I and j. Suppose that I is here, this is I at the moment, and this is j at the moment. Then compare the two with each other. However, if they are pointing to the same, then ignore it. So I'm going to just quickly write that logic. So if I is not equals to j, then only compare, then check. If s of I in s of j, then basically result dot add s of I. And then finally return result. Just getting rid of some indentation here. So basically brute force n square, scan everything. If the only condition is that they should not be the same string that we are comparing, then we can just check if one string is present in the another one. And if that is the case, then just basically return.
Himanshu, can you combine the two ifs? The two ifs, if I not equal to j and...
Yes, you can combine. You can combine the two. That is correct. You can. And I'm just quickly going to run. Let's see what happened here. Sorry, my mistake. I just keep inventing things on my own. So words, and this is words, not s. Okay. Name s is not defined. Let's run this code again. Still giving error. Let's see what the error is. List has no object. So you guys can see I'm doing too many mistakes.
Happened, yeah.
So I'm going to run this code again.
We have to add word of j or I?
If words I in words j, So we are checking if words I is a substring of the words J. So if that is true, then words I should be added, right? In that case. So now we get the answer, and the answer is working. So this is the conventional way you can do things.
So Himanshu, can we also use count method if words I dot count is count of words J if it is greater than 1?
You
Count
can
is
use
for strings, so no, but for string, no, I dot is I is index. So you won't get, I think you went to say index dot count, right? Or you're saying the import collections counter, that's a different game.
so the counts will actually match the whole string, right? But you want to match the substring. So
Okay.
if you have a list which has some words and you can ask for how many times, let's say, a certain word is present in the whole string, that you can do with the count function. But if you have to check if this is a substring of these many words, then what will you, then count will not return the answer in that case.
Okay, got it.
There's one approach I want to quickly show you as well. Okay, this instead of writing like this, there is an enumerate in Python, right? There is something called enumeration. So let me show you that first. Suppose you have, actually, let's just run a loop first. Okay, what I'm going to do is, let's just copy this because I'll upload this solution later on. I'm just going to quickly copy this and let's get rid of this guy. Let's write one more approach. So let's say the results is equal to an empty array. And instead of computing the length and going over the range and all that, there is, if I write, for example, if for W in words, print W, right? This makes life a little easy because I don't have to check the range and all that. So this gives me the answer like this. It fails, that's fine at the moment, I don't care. But in the similar way, you can actually write, there is a tool here which is called enumerate. So if I do something like enumerate words, let's just try it. Enumerate of words. Then this gives you index and the content in the same position. So you can write W comma I in words, print W comma I. Let's just write that for a second. When you do that, you notice that what enumeration does is it does both index and what it can get you both easily. So slightly opposite, I comma W. I'm going to use this as terminology. So you don't have to write really range. So I eliminate those two lines where I have to calculate the length and I write a range on that. I can just write for I, W in enumerate words. Then for J comma W in enumerate words. And now I can just quickly check if I is not equals to J and whatever, I comma, let's say W1 and W2. If I is not equals to J and W1 in W2, then result dot append W1. And then finally return result. Let's see if this approach works. Let's run the code and it works. So it's a slightly different way if you notice, but I'm just showing you so you know, you're aware of how else you can do this thing. Any question on this?
So
Himanshu, your time complexity is still the same, right? I mean,
Yeah,
any
the time
improvement, any other
complexity,
way, for O of n?
for the both of the
Is it
pieces
possible?
of code, the time complexity will be same.
Any O of n solution for this, or it's hard?
I can't think of any O of n solution, but you can reduce the complexity quite a bit by trying. Go ahead.
I have something here. Instead of doing 2 loops, I mean, we should do 2 loops, but what we can do is after you do enumerate, you can start with the next word, the second word. So the J loop will start with I plus 1. And every time you will check whether the length of the current word is greater than the new word that you're comparing in the J loop. So that will give you two options. One, if the length is greater than that, then you will check if the word exists in that word that you're comparing, and you will append it to the result. Or if the length is less than that, then you will compare the other way.
So that's
Right.
a very valid observation there. I agree with that. However, it will not simply work like that. So if you suppose consider this test case here, you have to do a little bit more. So if, let's say, we set a pivot on this and then another pivot here, J. So if you always move forward, then if you pivot as on S, it will go for hero and superhero. It will never go to mass.
So we already are checking both ways. Like when you take mass, you will check if mass length is greater than AS, then you will check mass with AS, or you will check the other way and add it to the result. So you don't need to backtrack of the things.
Agreed.
You will always move forward.
Agreed.
And you will compare based on the lengths of the string.
Cool. That's a valid solution. So basically the solution that being proposed here is basically, instead of doing all of this, you can always move forward by checking twice here. If W1 in W2, then result.append W1, and then another, if W2 in W1, then you can result.append W2. If I'm not mistaken, that is the solution being proposed, right?
Yeah, and J will always move forward from
Yes.
I+1.
Yep.
So
essentially you are saying that is correct. That is also correct. So instead of writing enumerate, you are going to write something like for I in range of L and for J in range of I to L. That's what you want to do. I+1 to L.
I+1 to L. Yeah.
Right.
Exactly.
So this is correct. This is correct. So let me show you something actually. Hang on. Let me go to the. So this was a problem which was given in the lead code contest last week. Okay, this was an easy problem, the first one in the lead code, and let me show you that problem and the solution that I submitted for this one. So this is called string matching in array. So what I did was hang on, where did my solution go? Oh, wow. Actually, I still may be able to find. Just give me a second. Nah, it probably was from a different computer. Okay, that's fine. So essentially what I did was, this is already O of n square. I sorted the whole array. So now everything is arranged. I sorted the whole array based on the length of the string. So in n log n time, you can sort the whole thing really quickly. And then after that, you don't have to worry about anything. You can always, the first loop. So if you sort it, let's just run on this test case. So if you sort this whole array, it will become is, his, verse, and universe. Now it's guaranteed that a substring for this can only be substring of anything forward. It can never be substring here. So from that point onwards, you reduce your search space by n square by 2. Essentially, that's the maximum you can do. My current algorithm that I've written on the screen is n square, and the algorithm that I initially wrote, this was n square, and this one is n square by 2. That's all. That's the only modification you can do.
Sure.
All right, let's look at the problem number 3, which was traveler.py. So let me look at the polls. If everybody has filled.
Himanshu, in the previous one, what are we saving by doing that optimized lookup?
Essentially nothing. Not a lot. Once again, as I mentioned in the.
Not yours, but not your technique, but the other one, the 2 if ones, like backward lookup if you're doing.
Essentially not much still. It's a slight optimization, that's all. Not much. So what you're saving is the total number of comparisons that are going to happen is all you're saving. brute force approach, the total number of comparisons are n
But we
squared.
are not breaking out, right? Like we are not breaking out, right? We are just still flowing throughout, right? In the previous, not your code, but I think one of the members was talking.
Yes.
So
So,
what are we saving? I didn't understand.
so what are we saving
Like
here?
still we are
Let's just go to
looping.
that.
Still we are looping only, right?
Yes. What are we saving? Let's just talk about that for a second. Okay. So suppose you have an array of 4 items. Okay. Suppose is, universe, verse, and let's say his. Suppose you have this. So my algorithm, the initially what I supposed suggested was that you take this pivot and you compare with everything else, right? So each item is going to be compared with all the rest of the items. So that is n multiplied by n square. That's what that is. Right? However, if by some trick you can only compare, the items that are in front of you, then essentially for first row you will do n comparison. For the next row you will do how many comparisons? N minus 1 comparison. For second row n minus 2 comparison. So that is the little bit that you can save there. So is first of all will compare with universe, verse, and his. Then universe will compare with only things that are in front of it, not in the back of it. So one comparison less each time as you move forward. That's all. So you keep on doing this, but this is still O of n square. So nothing changes here in terms of algorithms. Is that clear, or should I elaborate further?
And there was another technique one of the members was saying. What was his optimization?
So that's what I'm talking about. That's the
Same one. Okay.
Yeah.
Okay.
Basically, when what was suggested was that I in my code is checking whether is substring of this. So why don't we check both? If this is a substring of this and this is the substring of this, and when I pivot on universe, I don't need to go back further. I can just only go forward. But essentially,
Can you show that code? Yeah. What was that code change for that? Or
well, I mean, I don't know who was that. They can share the code to you. The number of comparisons are not less though. Just to be careful on that.
yeah, sure.
Yeah. Okay, third question, only 2 submissions in here. So let's see. Which is the traveler.py. It's not actually a difficult problem. All we are doing is basically we just have to parse this list and make a sense of direction using the first item of that each first element of each item. So suppose that I initialize this with 0. So these are my starting coordinates. Suppose these are my starting coordinates. Now I'm going to write for, let's say, the whatever direction comma distance in route. Suppose print direction comma distance. Right. So let's run this code. So you can easily parse everything. That's not a big deal, right? We are guaranteed that each item of this list is another list containing 2 items. So those 2 items can be assigned directly in 2 variables. So I'm writing for each item distance and direction in route. Now I'm just quickly going to check the direction. Suppose my direction is if direction equals, let's say, whatever, east, then x plus equals to, let's use the next line, x plus equals to whatever distance. And you can write basically an elif, or you can write another if. It increases the comparisons, but let me just write it this way. If direction equals west, then basically x minus equals to distance. And another one we're going to write, let me kill this guy. If direction equals north, then basically y plus equals to distance. If direction equals south, then y minus equals distance. And then in the end, just return x comma y tuple, or you can just return x comma y like that. So this logic shouldn't be that hard. Let me run this code first and see that it works. Oh, so it is working. The only slight optimization that you can do here is I'm using for if, so my code will be compared every single time. So either I can write this and write elif. That means once this condition is matched, I will just directly skip to the front of the loop. I will not do these 3 extra comparisons. That's one number thing one can do. Or we can add, so I can add elif here like that. Elif, and or finally I can just write else. Anything works. That's one thing that you can do. So instead of 4 comparisons, there'll be just 1 comparison in the beginning. But I mean, it's not a very big optimization. Another thing that you can do is you can add like a continue here. So basically I'm saying that if any of this condition matches, then you don't have to do anything further. Just go to the front of the loop. But once again, these are very minor optimization. They don't change any time complexity of the code. So you do that, you can run this code. Essentially, that's the piece of code. It's not at all hard.
So Himanshu, if you put continue, we don't need the else, right? We will directly bypass it.
Yeah, it will bypass everything. So continue means that at the point of time, stop, go to the front of the loop again. Any questions on the question number 3? Okay, so I'm going to publish the solution on the GitHub and the video will be available shortly. And
Himanshu, problem 1, I had a question.
Yes, tell me.
Yeah, I need the code actually. Yeah, problem 1.
Yeah.
Yeah, so here there's a return, right? So sorry, s of 0 plus star plus. So we are basically creating a new string, am I right?
That's right.
So is it like this is good, or we can use a replace, or like what is the best way to handle like?
No, this is a good way. I mean, so replace works. So here, if you know that a particular pattern has to be replaced with something else, then you can use the replace. But here I'm saying that the index 1 has to be changed to asterisk. So how will you replace?
I mean, replace can maybe also have a position, right? I mean,
I'm not aware of replace having a position. Does it?
I'll have to check if that is the case, but would that be better if that is true, or it has some other, or it makes not much difference?
I mean, even if it has, there's nothing better in it. So just to be...
No, because you'll be creating a new string, right? Here.
So even the replace creates a new string, just to let you know. Replace...
I think it overrides, right? Replace.
No. Replace cannot override anything. So strings are immutable in Python. So let's just try this out, okay? Basically, suppose you have s equals to, let's say, universe, okay? And now I'm going to say s dot replace, let's say I with at, assume that we do that. So we get this, it's a new string. S remains the same. S does not change. So
what if we want to do an in place update with that hash string?
dot replace. Let's just quickly go here. So replace is basically returns a copy with all the occurrence of the substring old replaced by the new. That's what the replace is. And these things are patterns. If that answers your question, Makrant.
Wait, if optional argument only the first, okay. So you are saying Oh, you're saying position is
it
not
returns a
applicable.
copy. So strings are fundamentally mutable data structure. Nothing changes in strings in place. You cannot change a string in place. So if you have, this is
So
Python.
if we do that s is equal to, yeah, go ahead, sorry.
If I write s of 1 equals to x like this, that will give me an error. List on the other hand are mutable. So you have
Yes,
list
correct.
2,
Yeah,
3,
yeah,
you have you can write L of 1 equals to 100. That is fine. But the strings will give you that error that they cannot
so
be.
if we do like s is equal to s dot replace or something.
Yeah,
So what
that is
still
a
you're saying
different.
is not.
So that is a different assignment. So if you can write something like s dot replace this, and you can write s equals to s dot replace. So this operation generates a new string, and the new string is assigned to s again.
Oh, okay.
So that's
So we are not saving anything.
yes, it does
Okay,
not
got it.
save anything in that case. So just a quick Python recap for you guys. So s equals to assume that it's ABC. Okay, that means that a string ABC is created in the memory, and s is boom pointing to it. Right now you write s dot replace. Let's say a with asterisk. So on this object, this applies, and it creates a new copy, which is asterisk BC. And if you write s equals to that, then essentially what that means is that this pointer, sorry for using the word pointer, actually it might be confusing. This reference changes to this guy. These are fundamentally immutable. They cannot be changed. Objects. You can reassign the name to something else. And also, to answer the other part of your question, string the replace works by replacing a pattern with another pattern. You're not saying that replace this index with something else. You're essentially not doing that with the replace. Okay, any questions? Any other questions?
Manchu, can you join that back in a way? Like, I mean, there is people, sometimes you can join back components. So then you are not creating an extra string.
What do you mean by that? Like join? You're talking about this join built-in?
Yeah. Yes, correct.
Join string function. No, so
I'm just trying to avoid an auxiliary string, extra string creation. That's why.
So what's the harm in creating an extra string?
Oh, space complexity, right? That's way. So creating an extra.
No, but
if
you have
join and somehow
that answer, right?
You're creating three strings. You're creating three strings, right? One is two extra strings you're creating with such a solution.
So what am I creating here is there is one character. So basically if the string is of size n, then I'm creating an n size string again, right? I'm returning a string which is modified, similar size string, right? That is the ask of the problem. Now let's assume that this is a string, which is ABC. I think what you might be meaning by in places, you cast it into a list first. And then you update whatever you want to do in the list itself. Let's suppose you put it asterisk, then you B, and then C. And then on that list, you call it join. You join this and it returns in a string, asterisk BC. If you're doing that, once again, you have not saved anything here as well. This is the list of the same size n, which generates a same string of size n. Right, the join basically is a function. The join that you're referring to, for example, suppose you have a list A, comma B, comma C, and suppose that is the list, and this is called L. If I do join L and I write this, that means no space, this returns a string. However, it's the modified string still. Your input is still not changed. In this particular problem, you're given an input string S, okay, which is this, suppose, n size. Once again, this piece of memory which is occupying this O n of space, it can never be modified. You will always have to create a new string and return that string. If, for example, I think so one confusion might be, let's say you are dealing with C, right? In the C, the strings are character arrays. There you can do this, if that helps. So in C, for example, a string s equals to ABC. It will not be written this way, but let's just assume for the simplification, it is like this: A, B, C, and /O, to specify that this is the last character. There you can do this. You can change the second character to something else, asterisk, and then C, and then /O, and then return the string. But here the string really is a character array. That's what a string here is. Does that answer the question, or still there's confusion?
I need to clear out some cobweb in my head. I'll look it up for the thing.
Right. Okay. Any other questions? All right, I'm going to end the session now, and I'll see you guys on Thursday for the interview lab. All right. Bye-bye. Thank you.
Thank you.